What's wrong with my work? This is one of the most common questions I get asked during my GMAT and GRE classes. It's not very uncommon for people to look at their work multiple times and still not be able to figure out their mistakes. And I have to come to the rescue and show them why their ideas do not work. Especially in probability related questions, I have noticed that sometimes multiple solutions look right even when there is a serious hole in the process. Let's look at this problem, for example. There are two ways in which people get the wrong answers in this problem, and both GMAT and GRE are pretty quick at putting those wrong answers in the answer choices. In other words, they will always try to sell you the wrong answers. The first way to get the wrong answer is if you do the square root of each term separately and then add and subtract, like this. When you do this, you'll get 2.5 minus 1.5 plus, 48.5 square minus 47.5 square. That's 1 plus 1 is equal to 2. Before I tell you what's wrong with this work, let's look at the wrong method too. Oh, sorry about the mistake. At this step here, it should be 48.5 minus 47.5, not squared. Okay, now back to wrong method 2. If you try to evaluate each pair separately and do the square root like this, 2.5 minus 1.5 squared plus 48.5 minus 47.5 squared, square root of the whole thing, you'll get the square root of 2. Now, some of you may have already understood why these two answers are wrong. But if you aren't sure why, let's look at another simpler example and we'll extrapolate that conclusion to this problem. As we all know, PEMDAS, or parentheses, exponents, multiplication, division, addition, and subtraction, is the correct order of operations in arithmetic problems. By the way, multiplication and division are done in the order in which they appear. Okay, let's look at this example. If we make the same mistakes we made in the previous problem, we will get the square root of 5 square minus square root of 4 square. That's 5 minus 4 is equal to 1. Or square root of 5 minus 4 squared, that is square root of 1 or 1. Okay, what if we express the square root in an exponential form, like this or this? Then it's pretty clear that the part inside the parentheses must be done before this exponent. And when we do that, we will get the square root of 25 minus 16, or simply square root of 9 or 3, which is the correct answer. Finally, let's go back to the original problem. As we learned from the previous example, the part inside the parentheses, or the square root, must be done before we take the square root. Now for GRE test takers, you can choose to use the calculator to get the squares and subtract, but that's going to be a very tedious process. And GMAT test takers don't even have that option, so you'll have to rely on either manual multiplication or find a clever way to do this quickly. Now GMAT and GRE will never ask you to multiply or divide if it takes minutes to do it, so there must be some short way to do these operations. Pattern recognition is your friend here. Notice that this is in the form of something squared minus something else squared. What does it sound like? If you said a squared minus b squared, you're 100% right. If you remember the formula, a square minus b square can be factored as a plus b times a minus b. Let's use this formula here. That will give you 2.5 plus 1.5, 2.5 minus 1.5 plus this. The next step is just addition and subtraction. That's square root of 100 or 10. Okay, if this was helpful and you want to practice one more problem, what about this? Let me know your answers in the comments. And as always, thank you for watching.